Start problem 9.29. A firecracker and a coconut blows the coconut into three pieces. Two pieces of equal mass fly off south and west, perpendicular to each other, at 20 meters per second. The third has twice the mass of the other two. What are the speed and direction of the third piece? Okay, like always, it's good to just draw a picture of what happened. So let's put this on our axes. Let me actually redraw these real quick. Okay, so we know one piece shot off straight west. We'll call it V1. And then we know another piece shot off straight south. We'll call it V2. And then the third piece shot off somewhere. So just by intuition, you can kind of guess the third piece has to shoot off this way, right? In order to conserve momentum. Now we might not know this angle right off the bat, but we do know that it had to fly off somewhere in this direction. So we'll call this V3. And so another thing to realize is that the initial momentum of the system is going to be zero, right? Like before it exploded. And so that means that the final momentum, the sum of all these different pieces also have to be zero. The sum of all these different momentums have to be zero. And so, the best thing to do is just to break it down to components. So, first thing to do is the momentum in the x direction, call it p sub x, is going to be equal to 0, right? Because we know that the initial momentum had to be 0, so the final momentum has to be 0. And so this is going to be equal to, these all have masses associated with them, right? So these two are just going to be m, this is going to be m, and this is going to be 2m. So the sum of all, so the momentum in the x direction has to be equal to 0, and so this is just going to be equal to v1 just is going to be all in the x direction, right, in the negative x direction. So we'll call this negative m v1. So that takes care of the momentum for this part. This part has nothing in the x direction, right? It's all in the y direction. But this one's going to have some component in the x direction. So we don't know this angle right here. It's called theta. But we're going to have to break V3 and it has a mass of 2m into its components. So we'll say plus 2m, right, because that's double the mass, times V3 cosine of theta. Now why did I do V3 cosine of theta? Because we want the component of this that runs along in this direction. And so these are going to be all of the, this is going to be the momentum in the x direction. And so if we rearrange this, we get mv1 is equal to 2m v3 cosine theta. And if you notice, these m's will cancel out. We'll divide out. And if we divide both sides by 2, we get v3 cosine theta is equal to v1 over 2. Okay, so this right here is just the x component of the momentum, of the final momentum, right? And we know v1, and we know we're given in the beginning, which is just 20. And so we know this component. This component has to be equal to v1 is just 20 over 2, so it's just going to be 10 meters per second. So that means that the x component of the third coconut piece that shot from this direction is going to have a velocity of 10 meters per second. Okay, so that's the momentum in the x direction. So now let's do momentum in the y direction. Piece of y. And again, it has to be equal to 0, right? Because it was the initial momentum for this entire system was 0, so that means the final momentum has to be 0 as well. And so this is going to be equal to, there's not going to be any contribution to the y direction from v1. And this one's going to be all in the y direction, but it's pointing downward, so we'll call it negative. So negative v2 times m. And then plus there's going to be some contribution from v3 over here to the momentum. So plus 2m times v3, and then we want just the y component, so this is going to be v3 sine theta. Okay, so now we're going to do the exact same thing we did over here. We're just going to rearrange this equation. So we're going to add v2m to the both sides, and so we get, I'm going to rearrange that too, just get m and call it mv2, so just flapping them, is equal to 2m v3 sine theta. Now again, we have the exact same thing where the m's divide out, and I'm just going to divide both sides by 2, and we're left with v3 sine theta is going to be equal to v2 over 2. So that was just all algebra, right? I just divided 2 by both sides and just switched which side these are on. And so v2 over 2, right, we're given that. v2 is just 10, so 10 over 2, and this is, v2 is 20, sorry. So 20 over 2 is just going to be 10 meters per second. And so now we know both our y components and our x component, right? This is our x component, v3 cosine theta, and this is our y component, v3 sine theta. And so so now we have our x and we have our y component. And so I'm going to redraw a triangle over here so you can see better what's going on and change colors too. So we have our x component and we have our y component. And if we want to find the magnitude of it, all we have to do is do Pythagorean theorem, right? We know this is 10 meters per second. It's my x component. We know this is 10 meters per second. That's my y component. And so to get that, all we do is c squared is equal to a squared plus b squared, right? And so now c squared is equal to 10 squared plus 10 squared. So c is equal to the square root of 200, which is equal to 14.1. This is going to be meters per second, right? So that right there is going to be the speed that the third piece shot off at. Okay, so now we need to figure out the direction that the third piece shot at. So again, we know the adjacent side and the opposite side. So if we call this theta right here, right? We can use the tangent, because tangent is just opposite over adjacent. So tan of theta is going to be equal to opposite, which is 10 meters per second, over 10 meters per second, opposite over adjacent. And so to figure out this angle right here, theta, all we have to do is inverse tan. So theta is equal to tan the negative 1 of 1, and this is going to be equal to 45 degrees. And that's going to be the angle that it shot off at. And so we have our speed and we have our direction, and that's it. So that's problem 9.29.